Okay, konting review lang, ano? We were discussing the phasor method of steady state AC circuit analysis. Analysis. Okay, so sabi natin step 1, you transform the network to the frequency domain equivalent. And how do you do this transformation? Your sources, you convert to phasors. Then your passive elements, you convert to impedances. Okay, and then step 2, you solve for the desired quantities in the frequency domain. And you're going to notice, or you probably already know, that solving for these quantities, puro algebraic, all the manipulations are algebraic. Then step 3, this is if necessary, because sometimes it is not necessary, because sometimes you already have all the information you need after step 2. But if necessary, you convert back to the time domain. The responses, convert the responses back to the time domain. Okay, so let's take another example. Ito yung exercise 4 dun sa notes ko. Given V of S is 100 cosine 10t volts. Okay, so this is an AC voltage source. Then I of S is an AC current source, 10 cosine 10t plus 30 degrees amperes. I want to find the time domain expression for I of X. Okay, so how do I go about that? So step 1, you transform the network. So we transform the network. We transform the circuit. Okay, yung V of S, okay, our transformed voltage source is going to be 100 over the square root of 2. So note, we're going to use the modified phasor transformation. Lalagyan natin ng square root of 2 sa baba. Okay, at an angle, okay, ang phase angle ng voltage natin is 0 degrees. Then I of S is 10 over the square root of 2 at an angle 30 degrees. Okay, sabihin natin this is Z1, okay. Ito, sabihin natin this is Z2, and let's make this equal to Z3. So Z1 is equal to 5 plus, okay, J omega L. 5 is in series with a 0.5 Henry inductance. The impedance of your 0.5 Henry is J omega times the inductance. Omega is equal to 10. So ito yung omega. Note that all the sources in this circuit have to have the same omega. Kung iba-iba yung mga frequencies ng mga sources dito, then you cannot solve it simply. You would have to use superposition to solve it. And your time domain expressions will be a little bit more complex. But in this particular case, all the sources have the same omega. So 5 plus omega is 10, L is 0.5, so that is 10 times 0.5 is 5. So 5 plus J5. Okay. Z2, which is a resistance, is just, by the way, this is ohms. No? Impedance is always ohms because it's a ratio of voltage to current. Z2 is 10 ohms. Z3, okay, this is minus J over omega C. Minus J over omega C. Omega is 10, C is 0.01. So that means omega C is 0.1. 1 over 0.1 is 10. So this is minus J 10. Okay, any questions so far? Okay ba?
Wala naman po, okay naman po.
Okay. So ano yung transform network natin? So the transform network, okay, meron tayong 100 over square root of 2 at an angle 0 degrees. Ito yung Z1, which is 5 plus J5. No? This is 5 plus J5. Ito yung Z2, which is 10. These are all in ohms. No? And then Z3 is minus J10. Minus J10. Okay, and then you have your current source. Okay, 10 over the square root of 2 at an angle 30 degrees. Okay, so ang solution 1 na gagamitin natin, okay, remember the problem is to find i's of x, no? So ang hahanapin natin dito is yung phasor i's of x. That is what we're looking for here, the phasor i's of x. Okay, so ang solution 1 is to use nodal analysis. So sa nodal analysis natin, let's apply KCL to this node, no? With this as our reference. Okay, so what do we want to call the voltage there? No? Let's just call this V of x. No? V of x. That's the voltage. That's the voltage at this particular node. No? Okay, siguro pwede mo akong tulungan. Ano yung nodal equation? Albert.
V of x over 10.
Okay.
Plus V of x over negative J10.
Okay.
Plus V of x minus 100 square root of 2.
Okay.
With the angle 0.
Oh.
Over 5 plus J5.
5 plus J5. Okay.
Minus 10 square root of 2 with an angle of 30 degrees.
Okay, very good. Kayang-kaya. Equal to 0, syempre, ano? Equal to 0.
Yes.
Okay. So, ito, isang unknown lang, no? You only have one unknown. So, we can solve for V of x. So, yan, i-practice mo na lang yan sa calculator, no? Yung pag-solve ng V of x. Bale, i-isolate mo lang yung V of x. No? Actually, madali lang naman. Ito ililipat mo sa kabila. Ito rin ililipat natin sa kabila. Itong term ililipat natin sa kabila. And then we can factor out V of x on the left side. And then you just form the quotient, no? And do you want to go through it or ano? Medyo okay ka na? Nakikita mo na how to do it.
Nakikita naman na po.
Okay, so you can solve for V of x. So, ang problem natin is if we want to solve for the phasor i's of x. So, pag na-solve ko yung V of x, paano ko makukuha yung i's of x?
V of x over 10 po.
Okay, so i's of x is just V of x over 10, no? So, makukuha mo na yung i's of x. Actually, pag nakuha mo yung i's of x, alam mo na yung RMS value ng current no? Kasi this will be a phasor, may magnitude, may angle. Alam mo na yung RMS value ng current. Pero dito hinihingi yung time domain expression. So ang gagawin mo na lang, i-convert mo na lang from a phasor, gagawin mo yung reverse transformation from phasor to time domain, no? So okay 'yon, no? May idea ka na how to do it, no?
Yes po.
Okay. What if I wanted to use superposition? So i-outline ko na lang din pag superposition, Pag superposition, okay, I have two sources, no? Dalawa ang source ko. So I can compute for ice of x using this source acting alone, and then I can compute for ice of x using this source acting alone. Okay? So for example, superposition. So the voltage source acting alone, okay? So ito ngayon yung voltage source ko, 100 over the square root of 2 at an angle 0 degrees. Okay. This is 5 plus J5, no? This is, lagay ko na lang J1, And then J2, J2, and then J3. Okay, ano mangyayari sa current source? When we want the voltage source acting alone?
Open circuit po.
Yeah, ang current source natin will be an open circuit. So i-compute natin ngayon yung, let's call it IX1. Okay? Yung phasor IX1. Madaming paraan para computein yung IX1. No? So we have to compute for IX1. This is the voltage source acting alone, no? So what are the different ways of computing for IX1, no? So one way is, okay, sorry. So again, kunwari this is V of x. Okay, what is V of x, Using voltage division, V of x is equal to 100 over the square root of 2 at an angle 0 degrees, okay, times J2 in parallel with J3 over J1 plus J2 in parallel with J3. Nakikita ba niyo yan? Can you see that? Kasi itong dalawa, these are in parallel, right? And then that is in series with this. So kung gusto kong kunin itong V of x, this voltage source multiplied by the parallel combination of these two divided by the sum J1 plus the parallel combination of these two. So masosolve mo na for V of x. Pag alam mo yung V of x, then IX1 is just V of x over J2. Okay? That's the voltage source acting alone. But that's not the only way you can compute for IX1. No? Madaming paraan. No? I could have, for example, used nodal analysis, kagaya ng ginawa ko rito. No? Nodal analysis to compute for this particular V of x. Or I could have gotten the equivalent impedance with respect to this source, computed for the total current, and then use current division. No? So you have plenty ways to compute for I of x. No? Now what about what about the current source acting alone? The current source acting alone. Ano mangyayari dito sa voltage source na to? Okay, it's going to, you're going to replace it with a short circuit, no? So ito ngayon, this is J1, this is J2, This is Z3. And then this is now my current source, which is 10 over the square root of 2 at an angle 30 degrees. And I want to compute now for Ix2. Ix2 is the component of Ix with the current source acting alone. So, any suggestions? Any suggestions for computing for Ix2? I can actually use current division. Use current division to compute for Ix2. Right? Ano yung current division formula? Do you remember? Okay, the current divides proportional to the not to the impedance, no? The current divides proportional to the admittance. Okay, so ang current divider formula mo would be Ix2. Okay, this is 10 over the square root of 2 at an angle 30 degrees multiplied by 1 over Z2, yun yung admittance, 1 over Z2, all over the total admittance. No? 1 over Z1 plus 1 over Z2 plus 1 over Z3. No? That's your current divider formula. No? It's just that pag dalawa lang yung impedance mo, it becomes product and then not product over the sum, no? Ano pala yun, no? Impedance in parallel pa yun. Pag dalawa lang to, for example, if kung wala itong Z1, Ix2 is Z3 times Z2 plus Z3, no? But since tatlo yan, we have to use the current divider formula. Okay. So pag nakuha mo na yung Ix1 and Ix2, you can now get Ix, that is just the two sources now acting together, Ix1 plus Ix2. And that's how you use superposition. Okay, any questions? Mel, you came in a little bit late. Nakahabol ka ba dun sa discussion? Are you there? Anyway, sige, tuloy natin, no? So, Thevenin's theorem. Pwede din natin gamitin yung Thevenin's theorem. So I just wanted to point out that you can also use Thevenin's theorem, no? Ano ang procedure for using Thevenin's theorem, no? So, where's our circuit? This is our circuit. Tatanggalin muna natin tong 10 ohms. No? Or take out Z2. So you remove Z2, that's step 1. Step 2, okay, you get the Thevenin's equivalent with respect to the Z2 terminals. Okay, and the number 3, you put back Z2 doon sa Thevenin equivalent, no? And compute for Is of X. So, ganun lang, no? So, if we removing Z2, okay, so this is 100 over square root of 2 at an angle 0 degrees. Ito yung Z1. Ito, no? Tinanggal ko na yung Z2. Then I have Z3. And then I have 10 over the square root of 2 at an angle 30 degrees. Okay. So I have to get the Thevenin equivalent with respect to these two terminals. So let me call this terminal A, terminal B. Okay. What is my Thevenin voltage? My Thevenin voltage is the open circuit voltage, no, between A and B. Remember that all my voltages and currents will be phasors. So my Thevenin voltage is the open circuit voltage between A and B. And how do I compute for this VOC? No? Again, I can use, when all else fails, you can go back always. No? Laging mababalikan mo yung node voltage method. Kasi the node voltage method, you can apply to anything. No? Yung ibang methods, yung mga simplification, yung mga ganon, that's just to make life a little bit easier for you sometimes. But you can always use the node voltage method. No? Actually, there's so many ways of solving this. For example, I could have converted this to a current source, and then I could have combined the current sources, and then combined the impedances, and then I could have gotten the open circuit voltage. So madaming paraan talaga. Okay, but anyway, if I make this my ground, this is also equal to VOC. Kasi itong voltaheng to is equal to the node voltage here with respect to my ground. So how do I compute for VOC? So using nodal analysis, okay, VOC minus 100 over the square root of 2 at an angle 0 degrees divided by Z1. So that's the current moving toward the left here. Okay, plus VOC, by the way, this is a phasor, over Z3 minus 10 over the square root of 2 at an angle 30 degrees. This is equal to 0. So I can solve now for VOC. No? So this is my Thevenin voltage. Okay, my Thevenin impedance. Since these are all independent sources, okay, kasi kung naalala niyo yung Thevenin theorem, depending on the nature of the circuit, no, there are different ways of determining the Thevenin equivalent. No? Pero pag independent sources, ano yung pinakamadali? Either of you two. Pag independent lahat ng sources, ano yung pinakamadali? Anyone?
Zero out po.
Yeah, ano i-zero out mo?
The dependent sources po.
Yes, you zero out the independent, no? Not the dependent.
Independent pa, independent.
Yeah. You zero out the independent sources, tapos anong gagawin mo?
Simplify na lang po the impedance.
Yes, that's right, no? So i-zero out mo yung independent sources, tapos i-simplify mo yung impedance with respect to A and B. No? So ang mangyayari, ang circuit mo na lang magiging ganito, no? Ito yung Z1, 0 na yan. Ito yung A, ito yung B. Okay? Yung Z3, tapos yung current source mo, Z0 mo, so open circuit na yan, no? So kukunin mo na lang yung impedance with respect to A and B. And what will that be? No? What will that be? What is, in effect, what is ZTH? No, that's the impedance with respect to terminals A and B. That's just going to be Z1 in parallel with Z3. No? In other words, ito at saka ito, nakaparallel lang silang dalawa. Okay? So the final Thevenin equivalent okay, I have my VTH I have my ZTH. And then now this is my A and B. So ano yung last step ko? Ano yung magiging last step ko? Since kanina ka pa sumasagot, Albert, what is the last step?
Ibabalik po yung impedance and compute for the IX.
That's right, no? So ibabalik ko ngayon yung Z2. Okay? And this is now going to be my IX. And you notice IX now is just VTH over ZTH plus Z2. And that's my last slide. So, yun lang, ano? Now the circuits that I showed are quite simple, no? But yun, what is a more complicated problem? A more complicated problem, you might see dependent sources. No? Pero pag may nakita kang mga dependent sources, the treatment is as you would have treated it sa resistive networks, except that you're now dealing with phasors and with impedances instead of dealing with DC quantities and resistances. No? So it's quite the same. No? What else? What are the possible complications? Kung gagamit ka ng nodal analysis, tapos meron kang floating AC voltage source, ano yung gagawin mo? Mel, are you with us? Nandiyan
Yes,
ka ba?
sir.
So kung magno-nodal analysis ako tapos meron akong floating AC voltage source, anong gagawin ko? Ano yung usual na ginagawa sa circuits na ganun, kahit sa DC, anong ginagawa?
Makalimutan ko na po, sir.
Okay, Albert.
Supernode po.
Exactly, no? Gagawin mong supernode, no? So, yun, yung mga techniques na gano'n, no? Magde-define ka ng supernode, kung may floating voltage source, kung may mga independent sources, you would manipulate it in exactly the same way, except that yun nga lang, no? You're dealing with phasors and impedances. Okay? So that is all, no? That's all I wanted to share with you this afternoon. So again, take a look at the notes kasi the notes are much more comprehensive. In fact, mahaba yung notes yata na naka-prepare. I just wanted to share this with you because it's for me it's illustrative of how to solve the problems that you will encounter in this particular module. Okay, so are there any questions? Mel, kung may mga tanong ka, now is the time, no? Kung hindi mo pa ma-digest, I guess you'll just have to take a look at the notes again later on. Any questions?
Digest ko na lang po muna, sir. Later.
Yes, try to digest it, ano? Kasi alam ko pag minsan mahirap talagang maintindihan without without looking at it more than once. Pag minsan kailangan tignan mo twice, thrice, and so forth, no? Okay, so if there are no questions, that's all. I said it was going to be a very short session. I'll close the session as soon as both of you leave.